Hi, for this video what we are going to do is we are going to find a critical value, and I have given an alpha that is not in a table. So sometimes you have to find the critical value without using the table. So what we're going to do is we're going to use the TI-84 to help us find that. Basically, if we draw out a picture, it can help us to see what we are looking for. Our critical value, depending upon your text, could be notated differently, but the critical value determines the rejection region. So basically with this one, what we're saying is that our alpha is 8%. So I want to find the z-score that corresponds to an alpha of 8%. So that would be my z star or zc, or z sub 0, depending upon how your textbook denotes it. So what we are going to do is if it asks for a left tail, then you are going to use inverse norm, and you are going to use your alpha with the 0 and the 1. Okay. And the reason we just use alpha is because the calculator is programmed from the left going up. For the right tail, what we have to do is we have to use inverse norm 1 minus alpha 0, 1. Because what we are looking for, again, if you have a picture, it helps us to see what we are looking for. This time we are looking for the alpha to be up here, and this, remember, becomes your rejection region. So you can decide whether you want to reject or fail to reject a hypothesis test. So that's the application of this. And then the last one, when you have a two-tail test, it is split between the two tails. So if we drew out a two-tail test, it's still a normal distribution, but this time half of our alpha goes down here and half of our alpha goes up here because it's a two-tail, so we split it in half. So the command for this one, if you were trying to put it into your calculator, is you would use inverse norm, and you would do half of alpha 0, 1. So let me show you how to find this in your calculator. So starting with the left tail, what we are going to do is I'm going to open up my calculator, and remember, to get to our distributions you would go second distribution, and we would choose option 3, the inverse norm. And our area, remember, our alpha was 0.08, and then we just simply go down here and hit enter. And I'm ignoring the left, center, and right because most people don't have that. If you have that, you can change it, but with this, I'm going to report it to 3 places, so this would be negative 1.405. For the second one, it should just be the opposite of this, but just to show you that you do get the same thing. So for this one, we would do second distributions, option 3. You could also go up and just use the one that you just did. This time we're going to do 1 minus 0.08. You can do the math beforehand and put in the 0.92, or you can just actually type in 1 minus alpha. And then hit enter and see you get the same thing, except for this time it's going to be a positive value. So a right tail is always positive, a left tail is always negative, and the two tail is always both. So let's look at the two tail. We would go in second distributions, option 3, and this time we would type in 0.5 times our alpha, or you could just type in 0.04. and hit paste and enter, and you get negative 1.751 approximately. Remember that you need both of them. So with this, it was approximately negative 1.751. And then our positive one would be positive 1.751. So if you wrote it as a lot of times, like especially if you're using technology to help you out, you would just fill it in as negative 1.75 comma 1.751. As always, thanks for watching.